So now that we know how to work rational exponents, we can simplify expressions that have rational exponents. So we have a big expression here, lots of exponents, lots of fractions. We're going to have to combine expressions using exponent rules, and then we can use the rational exponents if we need to write radicals. In our numerator, that's a power to a power. So we take this 1/10 power outside our parentheses, and we are going to distribute, which means we are going to multiply this to our exponents. So our numerator would change to x to the 5/10 times y to the 1/10. We can simplify the 5/10. I'm just going to leave it like that for now. The denominator is going to be x to the negative 1/2 times y to the 1/5. So we have a division problem, which means we are subtracting those exponents. We need common denominators. So 1/2 would actually change to negative 5/10. So 5/10 minus negative 5/10 is actually 5/10 plus 5/10, and that gives us 1. So we're going to have x to the first power. For the y's, same deal, we're subtracting 1/10 minus 1/5. 1/5 is equivalent to 2/10. So we'd get negative 1/10. So we have a negative exponent here, which means this negative exponent connected to the y has to go in the denominator. So y to the positive 1/10. And then we have x to the first power, and that would be your answer. So there's a whole bunch of different types of problems you can do with multiplying, dividing, adding, subtracting. But you want to combine all the fractions first. And then if you need to write this as a radical, you would write the 10th root of y in the denominator. And then x would be in the numerator. For multiple choice tests, these things are helpful. And then if you have to rationalize, depending on the class you're in, you might have to do that too. So have fun. So here's another type of a problem where there are rational exponents, but you should already have the skills to do this. So this is a special case of multiplying binomials, but we're not going to get into that. We're multiplying binomials here. Doesn't matter that you have exponents that are fractions. We're still going to do the same process. So we're going to do 5x to the 1/4, and we're going to multiply by both of these pieces. We're going to expand that out. And then we're going to take the plus 2, and same thing. So all we're doing is distributing all these pieces to make sure we simplify correctly. So we have 25x to the 2/4 because we add exponents when we multiply, minus 10x to the 1/4. And then we have plus 10x to the 1/4 minus 4. Negative 10x to the 1/4 plus 10 to the x to the 1/4 is 0. So this, if you noticed it right away, these are conjugates. So whenever you have a plus b times a minus b, binomials being multiplied, same terms, but one's plus and one's minus, that simplifies into a squared minus b squared. So that's a general rule that can help you do math a little quicker. But pretty much what this means is the middle terms cancel. We have negative 4, and here we have 25 x to the 2/4, which actually simplifies to 1/2. So that would be your answer. You might be asked to write this as a radical, in which case you have 25 times x to the 1/2. Those are separate. So the x to the 1/2 would translate into that radical. And you'd write your answer like this. Be wary of parentheses. This does not have parentheses, so the 25 has to stay separated.